Hi, and welcome to Lesson 1-5, Scientific Notation. Today we are asking ourselves the question, can I write very large and very small numbers using scientific notation? At the end of this, hopefully you can say, I can write very large and very small numbers using scientific notation. So the vocabulary we're going to learn today is scientific notation and standard form. There is an explore activity. And today we are going to learn first about scientific notation. And so we see numbers that do not contain exponents are written in standard form. So in our notes on the side, I'm going to write standard form. So standard form are numbers that do not contain exponents. So numbers that do not contain exponents. Okay. However, when you work with very large or very small numbers, it can be difficult to keep track of the place value. So we're going to be talking about place value, especially when we're dealing with very large or very small numbers. So our next word is going to be scientific notation. So if you have a highlighter, highlight this. This will also help you to quickly find it. If you don't know these words, this is going to be helpful. So scientific notation is a compact way of writing very large or very small numbers. So on the side, let's write scientific notation. And it's a compact way of writing very small or very large numbers. Okay, so we have standard form, we have scientific notation, and we're going to be going in between the two. So in words, scientific notation, so here we have scientific notation, and I would highlight this whole thing. This is going to be an important definition. Star it. Do whatever you need to do to know that this is going to be important. So it's a way of expressing numbers as a product of a factor and an integer power of 10. So when we're talking about that, we're looking at the fact that we have some number a. So on my side, I'm going to write a. That's our factor. So that's what we call a factor. And this factor has to be between 1 and 10, but cannot equal 10. And then we're going to say times 10 to the power of n being an integer being a positive or negative whole number. So when we're looking at this, so for positive numbers written in scientific notation, we have a, that's our factor, times 10 to the power of n, where a has to be between 1 and 10. It can equal 1, but it cannot equal 10, and n is an integer. So, for example, we have 425 million, and we can make it look like 4.25. So notice how the decimal went from being at the very end to being in between the 4 and the 2. And then we're going to multiply it by 10 to the power of 8. So if we have 10 to the power of 8, that tells us we have 1 with 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, comma, 1, 2, 3, comma. So notice how this is close to the number that we have. The only difference is it's just 1 instead of 425. So 100 versus 425. And that's why we're multiplying it by 4.25. so that we can get this number. In the opposite direction, notice how we have our decimal here and we end up putting it here. So notice how now we've moved our decimal all the way over to the right. And now we have 10 to the power of negative 5. So 10 to the power of negative 5 tells us that we have 1, 2, 3, 4, 5 zeros and 3. So 1, 2, 3, 4. But we put our decimal here because that tells us that we went from here to 1, 2, 3, 4, 5 places. Same thing with the 10,000. We're going from here 10 places. Oh, I shouldn't have a 3 there. I should have a 1. Because I'm just talking about my powers of 10. We had our decimal here. So we go 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 bumps. Okay. And we'll talk more about this. All right, so circle yes or no to determine whether each number is written in scientific notation. So remember, scientific notation, we have some number in front times 10 to the power of some number, and our number in front has to be between 1 less than or equal to a less than 10. So it has to be less than 10. It cannot equal 10. So when we look at this first one, do we have a 10 here? Yeah. So it's a no. For this next one, is this between 1 and 10? Yes. Next one, is this between 1 and 10? Yes. Next one, is this between 1 and 10? There's a 0 here. And if it's a decimal, that means it's less than 1. So this is a no. So if we check our answers, we get no, yes, yes, no. All right, first example. Write numbers in standard form. Okay, so we're going to go from scientific notation into standard form. Okay, so we're starting in scientific notation and then we're going to go into standard form. So this is what we're going to call method 1, and we have a method 2. So we're going to talk about this in a couple different ways. We have write 5.34 times 10 to the power 4 in standard form. So we're going to write the power as a product. So this is one way to do this. So we could just expand 10 to the power of 4. So that means we have 4 tens, 1, 2, 3, 4. We multiply all those out. We get 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1. So we have 1, and then we have 1, 2, 3, 4 zeros. 1, 2, 3, 4. Then we multiply these two numbers together. And so we should get 5, 3, 4, and I think one more. So we had 5.34 times 10,000. We plug it into a calculator, and then we should get our answer of 53,400. Next, we can just move the decimal point. I would say this would be my preferred method to do, because then I don't have to plug this into a calculator. Because I feel like that's a lot more work. Instead, all we have to do is count. So moving the decimal point one place to the right is a result of multiplying a number by 10. So we're going to move it to the right, and that equals multiplying by 10. So when you multiply a number by 10 to the power of 4, the decimal moves 4 places to the right. So that means the exponent on the power of 10 indicates the number of places. In this case, we had 4. A positive exponent indicates the direction to the right. So I would suggest drawing an arrow, or you can even write the word right. Or if you write the word right, also draw an arrow because I know I have to remind myself which way is left, which way is right. And so what that means is we're going to have what we have down here, and I'm going to make it a little bit bigger. So if I have 5.34 times 10 to the power 4, that means I'm taking the decimal. I'm going 1, 2, 3, 4. 1, 2, 3, 4. That means I'm going to have another 0 and another 0. Because every time we move the decimal over 1, we have to add a 0 to show that we're moving place value. So then my final answer, or I'm going to write it below it, is going to be 5, 3, 4, 0, 0, and our decimals at the end. And so we get 53,400. All right, go ahead, try the check, pause the video. Now that you've tried the check, remember when we have a positive exponent, we move whatever that is to the right. Okay, we move whatever that is, we move the decimal. So maybe I'll write move decimal to the right. So move decimal to the right. To the right. All right. So that means if I have 9.931 and I have a positive 5, that means I'm going to go 1, 2, 3, 4, 5. So I moved it here. I get 1, 2. So I should have 99310 because my decimal should be at the end. So 1, 2, 3, 4, 5. Double check it. And then I should have a comma. So I should have 993,100. Another way to think about this is if I have a positive exponent, that means the number gets bigger. If I moved my exponent to the left, my number is going to get smaller, right? It gets smaller. So going this way gets smaller. Going this way gets bigger or larger. So let's double check our answer. Yep, that's what we got. All right, next example. So now notice how we have a negative exponent. So when we have a negative exponent, that tells us we are going to the left because the number is small. That means we have a small number, and I can't write small. The number is small. So that means in method 1, when we plug this into our calculator, we have to write our 10 to the power of negative 1 as 1/10. And so we have 3 of those. So we have 3 1/10ths. We multiply straight across. 1 times 1 is 1. 10 times 10 is 100 times 10 gets us 1,000. So we take this decimal, and instead of this fraction, instead of multiplying by this fraction, we can also divide by 1,000. So we look at the definition of a reciprocal, and we should get 0.00327. And method 2, like I say, method 2 is my preferred method because I like to move the decimal. But method 1 shows us the math behind it. So if you like method 1, go ahead, do method 1. Method 1, if it makes sense to you, do it. If you feel like method 2 works for you, do method 2. When you divide a number by 10, the decimal point moves 1 place to the left. Dividing by 10 is the same as multiplying by a negative 1. So notice how up here we said that if it's a positive exponent, we move the decimal to the right and the number gets bigger. If it's a negative exponent, so negative exponent, we move the decimal to the left number gets smaller. Okay, so that means, so dividing by 10 is the same as multiplying by a -1. So when you multiply a number by 10 to the power of -3, the decimal point moves 3 places to the left. The exponent on the power of 10 indicates the number of places. In this case, we're looking at 3. A negative sign on the exponent indicates the direction to the left. So left, we're going left. So if we have 3.27 and we go to the left, we're going to go 1, 2, 3. So now our decimals here, we have 0 here, 0 here, and a 0 here. So that's why our answer is 0.00327. All right, go ahead, try the check. Now that you've tried the check, we should have 6.02. We have a negative exponent. So that tells us we are moving our decimal to the left. So negative exponent means we're moving to the left. And because it's a 4, that means we're going 4 places. So 1, 2, 3, 4. So we did 1, 2, 3, 4 moves. That means our decimal's here now. And we need to fill in our zeros in each place every time we move that decimal. So our answer should be 0.000602. All right, so let's check our answer. And that's what we get. We have these 3 zeros here, and then we have 602 here. So that's what we should have.